domain and range of multivariable function, we know that if D is a subset of R square, okay, then a function of two variable is a rule that assign each pair of xy in D a real number z is equal to f of xy unique real number. Okay, so this is what a function in two variable. So now we are going to determine where D is the domain, D is the domain, and the range is equal to is nothing but the collection of all z such that z is equal to f of xy for xy in from D. So if we consider a simple example, say z is equal to x square plus y square, and we want to determine, or f of xy is equal to, or f of xy is equal to x square plus y square, then the domain of this function is defined everywhere. So domain is equal to r square, okay, and range is equal to 0 to infinity. Since there exists, you cannot determine f of xy is equal to -1, that is, there does not exist x square plus y square is equal to -1. So the negative elements are not present in a range. Also, you can determine f of xy equal to 0. For example, f of 1 0 is mapped to 0, and therefore 0 is present in range. So the domain of the given function is r square, and the range is what? 0 to infinity. Again, if we consider second example, say f of xy is equal to 1 divided by xy, then the domain of this function is equal to collection of all xy such that x is not equal to 0 and y is not equal to 0. Okay, that is, you cannot consider such a pair f of 1 0, f of 0 1, or f of 0 2. Such a pair does not lie in domain. So again, the range of the given function, range, now again, there does not exist a pair f of xy such that f of xy is equal to 0. There does not exist a pair xy, such a pair in domain D. Okay, so the 0 not lies in domain range of the given function. Also, there you can determine, suppose you want f of xy is equal to say 100, then there exists pair x is equal to say 0.01 and y is equal to 1, then f of xy is equal to 1 divided by 0.01 into 1, and which is equal to 100. So there exists also you can determine negative element also. If you take minus 0.01 into 1, it is equal to -100. So the range of the given function there is minus, that is whole real number set minus only single element 0, that is minus infinity to infinity. Range is equal to minus infinity to plus infinity minus element 0. So if the f of xy is equal to 1 divided by xy, its domain is equal to x is not equal to 0 and y is not equal to 0, and it contains the range minus infinity to plus infinity minus 0. So here, if you sketch the domain of the given function, you can observe, suppose this is the x-axis and y-axis, then what is the domain here? You just skip this x and y-axis, then the domain is what? Here, this is the domain, that is, you have to skip this x and y-axis, all the numbers from on x and y-axis, then it is a domain. You can see here. Okay, this is the domain of the given function f of xy. Skip all the numbers from x-axis and y-axis. So if you skip these elements, these numbers from x-axis and y-axis, remaining elements are present, or remaining pairs are present in domain D. Next, if we consider one more example, f of xy is equal to, say f of xy is equal to square root of x minus y, then we know that square root function is not defined for negative numbers. So here domain is equal to collection of all xy such that x minus y greater than or equal to 0. To sketch the given domain, suppose we know that if we draw the first y equal to x minus y greater than or equal to 0 implies x is greater than or equal to y. To draw this inequality, first we convert it into equality. So x is equal to y. We know that this is what, an equation of line passing through origin. Now we are going to decide the domain, whether it is below the line or above the line. Suppose this is y equal to x. Now if you consider elements, say here this is the elements is what, 0 3, and if you plug this element here, number here, then we get 0 greater than or equal to 3, which is false. Okay, false statement. So what is our domain here? The domain is what, below this line y equal to x. So this is the domain. It also contains the given line. So this is the domain of the given function. Now we know that a range, to determine the range again there exists 0 is present in a range. That is, you can find a 0, f of xy is equal to what, you can find a pair xy such that f of xy is equal to 0. You can also find a pair xy such that f of xy is equal to, say, 100, 10. Okay, but there does not exist a pair such that f of xy is equal to -2, -3, -4, or negative element. So the range of the given function is from 0 to infinity. Now if you consider one more example, say f of xy is equal to 1 divided by square root of x minus y, then again we know that the square root function is defined for this term should be greater than or equal to 0, but since again 1 by 0 is not defined, and therefore the domain is equal to collection of all xy such that x minus y greater than 0. So this is the difference between the previous example and this example. In the previous example, it is same example, but the square root term is present on the numerator, and in this example square root term present on the denominator. So in the previous example, domain is collection of all xy such that x minus y greater than or equal to 0, but here domain is equal to collection of all xy such that x minus y is greater than 0. Okay, so to sketch the given domain, if you consider this is y-axis and x-axis, we know that again the y equal to x, since x minus y greater than 0 implies x is greater than y. And to draw this line x is equal to y, first we draw the line x is equal to y. We know that x is equal to y is the line passing through origin. Okay, since we use dash because here the points on the line not included in the domain. So what is the domain here? So this is again x less than or equal to y. Again you can see the difference between the previous example and this example. In the previous example, the points on the line is also included in the domain. Okay, but in this example the points on the line is not included in the domain set. Okay, so this is the domain of the given set. Again, what is the range here? Again, you cannot find here range. You cannot find f of xy pair such that f of xy is equal to what? 0. Such a pair does not exist. So the range is equal to 0, open interval 0 to infinity. So in the previous example, range is what? Close interval 0 to infinity, that is 0 less than or equal to x less than infinity. But in this example, it is what? 0, range is what? 0 less than x less than infinity. Now next, if we take one more example, say f of xy is equal to, say next example, say f of xy is equal to take one more example, square root of y minus x square. Now again, it is a square root function, so it is defined only if the domain is equal to collection of all xy such that y minus x square is greater than or equal to 0, that is domain is the collection of all xy such that y greater than or equal to x square. Now to draw the sketch of the given domain, again we can convert this inequality into equality equation, and if we consider few terms of the given function, say x y, given curve x is 0, y is 0, x is 1, y is 1, x is minus 1, y is 1, or plus or minus 2, it is equal to 4. From this information we can easily draw the graph of the given function y equal to x square. So it is what? Y equal to, say here, y equal to x square okay. So and again, if you consider inside this point, say it is what? 0 2, and if you plug this point here, then 0 greater than y is what here? Y is 2. So 2 greater than or equal to 0, this condition is true, and therefore the domain of the given region is, this is the domain of the given function. The domain of the given function, it is inside, it is also included, boundary point is also included here. So this is the sketch of the domain. This is nothing but the domain. Now again, to find a range of the given function, again you can find f of xy such that f of xy is equal to 0. You can find such a pair xy, that is if we consider 0 0, then the square root of this function 0 is what? 0. But you cannot find f of xy such that f of xy is equal to minus 3, minus 2. So negative numbers are not included in the range, and therefore range is from 0 to infinity. Okay. Now next if we consider one more example, say f of xy is equal to ln of say x minus y square, then again we know that this function is defined, the logarithmic function is defined only if x minus y square is greater than 0, that is x is greater than y square. So the domain of the given function is equal to collection of all xy such that x minus y square is greater than 0, that is x is greater than y square. So if you convert this x is equal to x greater than y square into equality, we get x is equal to y square. Again, if you consider few terms of the given function or given curve xy, if y is 0, x is 0, y is 1, x is 1, y is minus 1, it is 1, and for 2 it is 4, and minus 2 it is again 4. So if you draw given logarithmic domain is what? X is greater than y square, so the boundary point is not included in the domain. So okay, so now we are going to decide. If we take the inside point here, say inside point is 2 0, and if you plug this point into x is greater than y square, then 2 is greater than 0 is true condition, and therefore the domain of the given function is, this is the domain of the given function. Okay, now next, now we are going to decide the range of the given function. Say f of xy is equal to, now we want to determine range of function f of xy is equal to ln x minus y square, So here you can easily find a pair xy such that f of xy is equal to 0. That is, for example, if you consider here f of 1 0, then f of 1 0 is mapped to ln 1, which is equal to 0. Also you can find xy such that f of xy is equal to, say, minus 2. Also you can find xy such that f of xy is equal to 2. Okay, and so on. That is, you can obtain positive as well as negative point. 0 is also you can there exists a pair such that f of xy is equal to 0. So here range is equal to the real number, that is r, that is 0 less than minus infinity less than x less than infinity. So now next, instead of x, I am writing here minus infinity to plus infinity. So this is the range. If we take one more example, say f of xyz is equal to 1 divided by x square plus y square plus z square, then this function is defined. F of xyz is equal to, domain is equal to what? Domain is equal to, now this function is defined everywhere except if x square plus y square plus z square is equal to 0, and we know that x square plus y square plus z square is equal to 0 has only solution if x is equal to 0, y equal to 0, and z is equal to 0. So what is the domain here? Domain is equal to r cube minus the only singleton point we want to remove here, 0 0 0. Now range, again you cannot find a pair f of xyz such that f of xyz is equal to what? 0, or f of xyz, you cannot find f of xyz which is equal to negative k, or negative 2, negative 3, negative 4. So the range of the given function is 0 to infinity. So if we take one more example, say here f of xy is equal to, square root of x plus y. Again, say x plus y, we know that this is a square root function. It is defined only, what is the domain here? Domain is equal to collection of all xy such that x plus y greater than or equal to 0, and therefore domain is what? X plus y greater than or equal to 0 implies x is greater than minus 1. Again we know that x is equal to y is the line passing through origin. So if you consider a line passing through origin, so the domain may be present above the line or below the line. So x greater than or equal to minus y, if you consider any point from this region, if you consider this point here, say it is 0 2, and if you plug this point here, that is x is 0 and y is minus 2, this condition is what? Y is equal to x is greater than minus y, and this condition is true. That is 0 greater than minus 2, this condition is true, and therefore the domain of the given region, the given function. This is the domain. You can see this is the domain. Sorry. Okay, this is the domain of the given function. Now we want to determine range. This is what? Sketch of the domain. Now given function f of x y is equal to what? Square root of x plus y. F of x y is equal to square root of x plus y. Now you can find a pair such that f of x y equal to 0, but you cannot find a pair such that f of x y is equal to minus 2, negative values. So positive you can determine. So range is again from 0 to infinity. Now next, if you consider one more example, say f of x y is equal to f of x y is equal to square root of 1 minus x square by 9 minus y square by 4. Again it is a square root function, so its domain is equal to collection of all xy such that 1 minus x square by 9 minus y square by 4 greater than or equal to 0. That is if we solve this inequality, we get 1 minus x square by 9 minus y square by 4 greater than or equal to 0. So this implies 1 is greater than or equal to x square by 9 plus y square by 4, that is x square by 9 plus y square by 4 less than or equal to what? 1. So so you can, this is an ellipse having major axis is 3 and minor axis is 2. So if you sketch the given say here on x axis it is 3, say 3 and minus 3, on y axis it is 2 and minus 2. So this is the say sketch of the given domain. Okay, so x square plus y square, this again since it is less than or equal to 1, so this is the point here we satisfy. This is the domain of the given function, and since it is a square root function, this is what sketch of the domain. Since it is a square root function, its range, again you cannot find, I am writing here one more times, f of x y is equal to square root of 1 minus x square by 9 minus y square by 4. So since you can find a pair such that f of x y is equal to 0, but again there does not exist negative numbers, and you cannot find f of x y which is again what f of x y is greater than or equal to 1. So here range is equal to 0 to 1. Okay, that is if we consider her x is equal to 0, y equal to 0, then f of 0 is equal to what? Square root 1, it is 0. Okay, so and if you consider here x is equal to say here 3, x is equal to 3, f of 0 is mapping to square root of 1 minus 1 which is equal to 0, and therefore the range of the given function is equal to 0 to 1. There does not exist a pair such that f of x y is equal to 2 or f of x y is equal to minus 2, say 3, and therefore range of the given function is 0 to 1. Thank you.